You ever wonder how a computer can invent something that feels completely new? Like a word that's never existed before. I mean, it feels like magic, right? But it all comes down to two surprisingly different paths that somehow lead to the exact same place. Let's break down how it all works.
So take a look at these names. Dantel, Irad, Zendi. They sound kind of plausible, right? Like you might have met someone with one of these names. But here's the thing. Every single one was generated by an AI that was just trained on a big list of real names.
So yeah, that's the big question here. How can a machine, which is really just following instructions, actually learn the vibe, the pattern of human names well enough to make up its own? Today we're going to pull back the curtain and look at two totally different ways to solve this puzzle. One is super simple, the other...
Okay, so our first path is the super straightforward one. You can think of it as the statistician's way of doing things. It's all about just observing and counting. No fancy learning, just raw data. It all starts with this really simple idea called a bigram. A bigram is nothing more than a pair of letters that show up next to each other. So, in the name Emma, the bigrams are EM, MM, and Ma. And that right there? That's the basic building block for this whole method.
The logic here is honestly beautiful in its simplicity. Think of the AI as this super meticulous accountant. First, it just reads a huge list of data, in our case, about 32,000 real names. Then it just starts counting. It goes through and notes every single pair of letters it sees. How many times does an A follow an M? How often does an H follow an S? Finally, it takes all those raw counts and turns them into probabilities. That becomes its rulebook for creating new names.
And what you're looking at here, this table, this is the brain. That's it. This is the entire model. All it says is, okay, if the last letter was M, there's a 12.5% chance the next one should be A. It's just a simple lookup table, based entirely on what it saw in the real world.
All right, so that was path number one, nice and easy. Now let's get into path two, the learning method. This one is way less direct, and honestly, at first, it feels a lot more mysterious. And really, the difference here is all about philosophy. The counting method is like a detective, meticulously putting pins on a clue board, calculating facts directly from the evidence. The learning method, though, that's more like a student who only learns by making mistakes. Thousands and thousands and thousands of them.
So here's how that learning process works. The whole thing starts with what's called a neural network, which is basically a brain just filled with completely random numbers. It then tries to guess the next letter in a name, and of course its first guess is totally wrong, because its brain is random. It then measures how wrong it was, and it uses that error to go back and just slightly tweak all of those random numbers to be a little less wrong next time. And the key is it does this again and again and again, in this case 228,000 times.
So, we have these two completely different ways of thinking. One is simple counting. The other is this complex, repetitive learning process. You'd think they'd end up with totally different answers, right? I mean, one's just counting, the other is this complicated learning thing. Well, this is where it gets really, really cool.
You have these two roads, right? Built with totally different tools and philosophies. And it turns out, after all that, they both lead to the exact same place.
I'm not kidding. After all those hundreds of thousands of rounds of trial and error, the final numbers that the neural network ends up with in its brain become mathematically identical to that simple probability table we made by just counting. The learning model doesn't find a similar answer. It slowly, painstakingly rediscovers the exact same statistics from scratch.
Okay, so this brings up a super obvious question, right? If you can get the exact same answer with the simple counting method, why on earth would anyone go through all the trouble of that complicated learning model?
The whole answer boils down to one single, incredibly important word: scalability.
See, this is where that simple counting method just completely hits a brick wall. Our bigram model only remembers one letter, the one that came right before. But what if you wanted to generate a whole sentence? You might need to remember the last 10 letters to make sense. Well, the probability table for that would be so big you couldn't even store it on a computer. It's just impossible. The counting method just can't scale up.
But the learning approach? It doesn't need those giant tables. Its whole trial and error thing is flexible enough to learn way more complex, long-range patterns without needing infinite memory. And that ability to scale is exactly why it's the foundation for the massive AI models you hear about every day, like GPT. So just think about that for a second. We just saw the incredible patterns an AI can figure out from just a little list of 32,000 names. The question I want to leave you with is, what do you think it's learning when its textbook isn't a list? but a massive chunk of the entire internet.